All right, it is 10:30, so I'm going to go ahead and get started. So my name's Kyle Gupton. I'm a director of engineering at Tableau. I work on teams that help you create beautiful content to communicate your ideas effectively. So things like dashboarding, storytelling, formatting, all of those sorts of things that you do in Tableau. So around 15% of people in the world have some form of disability. That equates to about 1.1 billion people worldwide. Somewhere between 110 and 190 million adults have disabilities that make it difficult for them to function in their everyday lives. Accessibility is about designing the systems that we use as people to be able to be used by people with disabilities so that they can better fully engage in life and society. And so this is what this session's all about, is bringing those ideas of accessibility to the content that we create in Tableau. So what I want everyone to get from this session, several things. First is a basic understanding of what accessibility is and some of the various concepts and laws around accessibility. Second, an understanding of some of the major standards for accessibility, how to apply those accessibility standards in Tableau, and then things that we're doing in the product to make all of this a reality. So let's get started with the basics. So accessibility is the usability of a system by people with disabilities. There are many kinds of disabilities that we're talking about here. They could be visual or hearing or cognitive or motion, motor control. Each of these kinds of disabilities requires a different type of accommodation in whatever system that we're talking about. And different degrees of impairments require different levels of accommodation in the system. And so one of the things as it relates to computer systems are things called assistive technologies. So accessibility is all kinds of systems, could be a wheelchair ramp, and so forth, but we're talking about computers here with Tableau. And so AT or assistive technologies are mechanisms by which we make computers accessible. To give you an idea of what some of these look like, for limited movement, keyboard use or mouse use can be difficult or impossible. So there are devices. On the left, we have a picture of what's called a keyless keyboard. It basically allows someone to use a keyboard if they have pretty, severely limited mobility in their hands. Or on the right, if there's no mobility, something like a sip and puff switch can be used to operate the keyboard. And so that's the kind of device that you use it's like a straw that you suck on and puff on. It can be used commonly to operate wheelchairs and other things, but including computers. For vision impairments, there are a number of different technologies as well, kind of beyond just the ability to zoom in and such, which is standard on most computers. A refreshable braille display is one of those. Basically, it's like a device with little pins underneath it, and it can basically display in braille lines of text that are coming from the computer. Somewhat more common and something people may be more familiar with are screen readers. So these are basically pieces of software that read to you text that's on the screen. They also come with keyboard commands that you can use to navigate programs, navigate web pages, and so forth. Two of the most common ones are JAWS for Windows and one called NVDA, which is an open source screen reader. There are also ones that come with operating systems now, VoiceOver on Macintosh, also on iPhone devices or iOS devices, and then Narrator on Windows. So those are all built into the operating systems, though the most common ones used are JAWS and NVDA. JAWS is relatively expensive. It's a couple $1,000s for a license. NVDA is actually free. It's an open source freeware product. All right, so I want to talk a little bit more about vision impairments in particular, because a lot of the computer accessibility guidelines and technologies are around vision. And obviously vision is critically important to the work we're doing in Tableau, since it's primarily a visual-based product. So there's a big, wide scale of vision impairments out there. Some of them are pretty common. Color blindness in men is pretty much the most common. About 8% of men are red-green colorblind, so can't easily distinguish between those two colors. About 0.5% of women, just to give you an idea. So altogether, we're pushing 10% of people have that particular visual impairment. So to give kind of a better idea of what some of these might be in the spectrum, I put together some simulations of what they might look like to someone. So as the basis for the simulation, I have a screenshot of a viz that many people might be familiar with. It's shipped as an example with Tableau for a long time. It basically shows, for a hypothetical university, distribution of SAT scores across various schools within the university or colleges within the university, also split up by male and female scores. So the top graph on the left, or the top graph is by school, and the bottom histogram is by gender. So the first simulation is of red-green color blindness, actually a particular kind of red-green color blindness, and I'm not going to try to pronounce it because I'll probably get it wrong. It's a medical name. So you can see that the colors change, or maybe if you're red-green colorblind, it looks the same. The colors change and it becomes difficult to distinguish the marks from each other. This next simulation is no color vision at all, so it's all grayscale. This is a real thing. And so you can see in the bottom histogram where the marks, the only way you could tell them apart was their color, you can no longer tell those marks apart from each other. They're all the same color. Contrast sensitivity loss. This is quite common, and in fact, even if you have correctable vision, you do have some contrast sensitivity loss, the less visual acuity you have. Someone with low vision is a simulation of low vision where this might be as good of acuity as you can get even with correction or surgery. And just in case you're wondering, a visual disability or impairment is defined as a non-correctable issue. So something that's not correctable by surgery, glasses, or medication. And then if someone has no ability to perceive light at all, this is what it looks like. So obviously this is perhaps a bit of a conundrum for working with data visualization software. Our mission is to help people to see and understand their data. And Tableau specifically leverages vision, which is our most powerful sense. About half of the human brain is devoted to processing all of the information that comes in from our visual sense. So when you think about it, you kind of have to think about what you can accomplish and what the goals are about making visualizations more accessible. First is, remember, these exist on a spectrum. It's not, great vision or totally blind. There's a whole number of things in between that. And so accessibility is about making the visualization itself more usable by more of those people. And then for someone who can't see at all and has complete blindness, it's about making sure they have access to the information that's in the visualization, the actual data that's there. They won't be able to experience it in the same way, obviously, but they can still get at the key information that's part of it. So going into just a little bit of the legal framework, because I know that is kind of why a lot of people get involved in accessibility. So the main one in the United States that we talk about is Section 508 of the Rehabilitation Act of 1973. This is something, it's a US federal law, and it governs how you can, by information technology, deploy programs and information using information technology. How many here work in an environment that's subject to 508 regulations? All right, pretty much what I expected. That's why you're here. And it also, because of the law, if another, say, government, smaller government, or like a state or local government receives federal funding, Section 508 then applies to them and so forth. It also works for universities as well. The Americans with Disabilities Act is another law that has a lot to do with accessibility. It's mostly around, I'm not a legal expert, so don't quote me on this, but it is mostly around physical structures, so making sure that buildings are accessible and so forth. It's a bit of a gray area as it comes to software. There's been a fairly mixed legal record on whether or not it applies to, say, public websites of companies. And there have been court cases decided either way. And my understanding is that there's meant to be some clarification from the Department of Justice on, what it actually applies to and what it doesn't. In the UK, there's similar laws. The Equality Act of 2010 is what's in the UK. And in the EU, there's a proposed law, it has not yet been passed, called the European Accessibility Act. And I have links at the end of this presentation to all of these resources and a bunch of other stuff throughout. So why care about it? And there are a number of really good reasons to care about accessibility. One, and perhaps the most obvious, is that you care about helping people with disabilities more fully engage in the world. And making sure that your work that you do in Tableau can reach the largest possible audience. Another thing that people don't think about very much is that many accessibility practices are actually just good usability practices in general. A great example from the physical world are wheelchair ramps. So wheelchair ramps obviously help people with wheelchairs get places and into structures, but they're good for many people. So if you have a stroller, for example, you can use a wheelchair ramp much more easy than taking it up steps. So that's a good example of good usability in a physical space that was good usability for many people that was done for the purpose of wheelchairs. Depending on your environment, it might be the law. So in particular, if you work in government, it might be the law that you produce accessible content. Or your organization may have its own requirements. Something that we're seeing is that many companies are actually starting to adopt internal accessibility standards. So it's not just a government thing anymore. And that trend is increasing. We see it more and more from our customers, that especially some of the larger customers are doing this. Okay, so I want to scope down the problem a little bit to really get to the meat of this presentation because software accessibility is a pretty big topic and our product line has a lot of surface area. So when we started kind of paying attention to this subject, we had to make a choice about how we were going to prioritize our work. And we wanted to make sure that what we were doing from our own internal engineering efforts was going to affect the greatest number of people possible. And so, one thing that's true is that the vast majority of people who interact with Tableau in some way do so through published content that's already previously been created. So published to one of our platforms, Tableau Server, online, or public. And so that's what we're focusing on, is web content accessibility. So we're talking about the things that you publish and access via a web browser. So that being given, let's talk about the standards for web accessibility. So with web accessibility, there actually is a widely accepted and adopted set of guidelines, and they're called the Web Content Accessibility Guidelines, or the acronym is pronounced WCAG, is how that's done in the business. So these are standards and guidelines published by the World Wide Web Consortium, which is the standards body that basically publishes all the standards for how various pieces of the internet interoperate. So, how do servers talk to clients and all that sort of thing. And they are a set of recommendations for how to make web content more accessible. And they address a wide variety of disabilities and concerns. One of the other things that they do is they establish standards for how assistive technologies like screen readers interface with web content, so that you can have a piece of web content and then some screen reader, and the screen reader will know how to make sense of that web content. And so any screen reader will work with it. And so it's a standard thing. They're also the international reference standard. So basically the thing with WCAG is if you go with WCAG for web content, you're good. That is the standard. Section 508, the law doesn't actually specifically reference the WCAG standards right now. Section 508 is a little bit higher level than the WCAG is. The WCAG is quite detailed. But if you follow the WCAG guidelines to a certain level, then you're good for 508. Also, there's meant to be a refresh of the 508 guidelines that specifically adopt the WCAG guidelines. And I have some links about that on the government website that talks about 508. So yeah, the WCAG guidelines are basically our reference here. So let's look at what they're like. It's actually a pretty easy to read document. I encourage anyone who's kind of getting involved in this to actually go and read the standards. The website has the standards and a lot of great examples and Q&A about how to implement them, and it's pretty readable and understandable. It's not that difficult to get into. So this presentation will give you a good outline of what those standards are and how they apply to Tableau content, but I do encourage everyone to really kind of read and understand the standards themselves if you're trying to create this kind of content. So the way the WCAG is organized is in 4 principles, and each principle has a number of guidelines associated with it. So the first principle is perceivable. It basically says that the information in a web page, as well as any UI, interactivity in the web page, has to be presentable to users in ways that they can perceive. Usually this means things like text, so that a screen reader can read it if someone cannot visually appreciate the interface. Also needs to be operable. So basically, the UI components must be able to be operable in a way that a user can operate them. Be that with hands or some kind of other input device like a sip and puff switch. The next 2, understandable. So basically, the information and the operation needs to be understandable. For our purposes, this actually gets a lot into clear instructions and names and labels in the interface so people understand how it works, so they don't have to divine how it works by trial and error or so forth. And then finally, robust. And this is when it gets back to the interfacing with assistive technologies. It's basically saying that the web content itself needs to work with standard assistive technologies, both now and in the future, provided those technologies also adopt these standards. So in WCAG 2.0, which is the current version, there are 3 levels of conformance. They use the word conformance rather than compliance. So the first, kind of the minimum standard, is called A. So it's an A rating. The way the WCAG is organized is there's a bunch of statements, it does this, it does this, it does that. And some of them will be tagged with A, some with AA, some with AAA. And so if you are trying to make something AA, then it has to satisfy all of the A and AA requirements, is how that works. AA is actually the most important one to target. A is very minimal. AA is really the standard. And that's what, if like government agencies test for, is AA conformance and so forth. And that's the one that we will target. AAA is quite stringent, and it's not all that widely used because it does impose some pretty significant design constraints as to what the web content can be. So AA is really the focus. And so that gets us to what is our goal here when it comes to accessibility for Tableau content. Our goal is to basically enable Tableau authors to achieve WCAG AA conformance for content they produce in Tableau when it is published to one of our platforms and embedded inside of a WCAG conformant web page. Now, you can't do that right now. It is impossible to do that right now in Tableau for a number of different reasons. And the rest of the session is going to talk about kind of what actually has to happen, both from the content perspective as well as from the tool perspective. Sorry, I keep hitting my microphone. And so let's get into that. So if you kind of take the WCAG and cross out everything that doesn't apply to Tableau content, the list gets much shorter because there's a bunch of stuff in it about hearing and some other disabilities that don't generally apply to Tableau content. Also some multimedia stuff that could apply because you can certainly embed like a video or audio inside of a dashboard, but I left that out because it's not strictly Tableau content. I wanted to focus on what you do in Tableau. So if you look at the WCAG and you take out all the things that don't apply, you end up with a number of different guidelines. So in the left column, it's stuff that is the responsibility of the author to do. In the right column, it's something that the tool has to do. So we'll go through these in detail and how you do them in Tableau, but basically, the author is responsible for making sure that there are text alternatives for information that is in a non-text format in, say, your visualization or dashboard and so forth, and making sure that you have good instructions and explanations for how to operate it. One of the things that we have to do is make sure that you can operate the visualization and the dashboard with a keyboard. You can't do that right now. You can't get into a visualization, manipulate filters, and so forth. That can't be done. We're working on that right now, actually. Some of these things you have to do intentionally, which is what this session's about. And some things, when we finish the work, it'll just be there. It'll just happen for you. You won't have to do anything for it. So keyboard navigation is one of those. It'll just work. The next set of areas are under understandable, and there's a bunch of other stuff that we have to do here to make sure that Tableau works with assistive technologies and that things work in a normal, reliable fashion, meaning there's a clear, say, tab order as you keyboard navigate into a viz, and it's makes sense and operates the same way every time. So these are the things that we're working on that will just work once we're done with it. So now I want to focus on what you all have to do when you're making content that is meant to be accessible. So if we distill it down even more for Tableau authors specifically, we have a much shorter set of guidelines. This is actually a pretty big subset of the WCAG guidelines, actually need to be things that you're thinking about as an author. So let's go through that and talk about how you author for accessibility within Tableau. And this will be a combined thing. Like I said, it's stuff that we're doing and stuff that you're doing in the content. So that kind of brings up the first thing that we all realize, or need to realize, is that accessibility is a design choice. There will never be a day when you can just flip a switch on a viz and it will magically become accessible. There are choices you have to make in the design of the content in order to make it accessible. And not all visualizations are going to lend themselves to some of these things. And some of the guidelines you're going to see are a little bit different than maybe some of the typical techniques you see for creating great visualizations. They're a lot more wordy. There's a lot more text that explains how to use the visualization that you might not find on some of the fancy dashboards and stories and such, especially a lot of the Tableau public content, that sort of thing. So that, is kind of a first thing to realize is you have to, do this intentionally. This is an intentional choice that you're making in order to make something accessible. And so as I've gone to the conference and I've sat in a number of sessions where it's, people are like, these great techniques. It's like, yeah, that's good, that's awesome, but it doesn't work for accessibility. So many of the things that people do, if you care about accessibility, they're kind of off the table. I actually just went to a great presentation about, it was called Gorilla Dashboard Usability, something like that. And basically they were talking about user-centered design in the design process. And they didn't specifically address accessibility, and it wasn't the topic. But the whole idea is that you start out your design process by analyzing your user and what your user's needs are. And so these two things really fit together, because if you have users who have the need for accessibility, then you have to design for it. All right, so let's go into it and get started. So the first big thing, and this is a huge one in Tableau, is about having text alternatives for non-text content. And of course, a visualization is a lot of non-text content. So this is key for a Tableau visualization. So best practices here, there are a number of things. Tableau has view data functionality, so you can see the data that's behind a visualization in a tabular format. We're working today on making access to that view accessible and the view itself to be accessible. So you'll be able to, for example, tab into a dashboard and then hit a particular keystroke, and it'll bring up the data that's behind the visualization in a tabular form, and then you'll be able to use a screen reader and the keyboard to navigate through all of that data and have it read to you. Did you have a question?
I do.
Oh, yeah. Sorry.
For some of the information that I display on Tableau Public, I suppress it and I don't allow people to download the information. Do you think we'll be able to, for example, use view data, but not show those suppressed values? I'm in public health, so we may have to suppress things for privacy reasons that we have in our underlying data, but we don't show in our visualizations.
So when you do view data in Tableau, it only shows the data that's in the visualization. It doesn't show the entire data set. Yeah, there's 2 tabs. So is that what you mean, like be able to not show the full data or just the data that's in the viz?
Counts of 5 get suppressed. So
Counts of
below 5 get suppressed. So they don't even show up in the table, but they are in the underlying data.
Okay.
So you can't pinpoint specific patient. Like there's 10 patients here, but I can't tell which one of it has this specific diagnosis detected.
Got it. Okay.
Just at the 1 record level, but they always go to 5, 6, 7 records.
Okay. All right. So being able to just show the data that's in the viz itself is what you're saying that needs to be done, and not the full data. Okay. We're actively working on it now. That's really great input.
Is there a form that we can put our ideas through? Because mine's kind of an idea on hers. When you turn off the command buttons at the top of the tooltip, you lose keep only, exclude, group, set, view data. If for accessibility, I want to keep view data, can we disable the other 4 and choose which buttons show up at the top of the tooltip?
So accessing it wouldn't be through the tooltip. It would be through a keyboard command when the viz has focus with the keyboard. So because doing the tooltip is a little tricky. So yeah. So let me keep going and make sure I get through all of it and answer questions more towards the end. So another thing that you can do is to have an HTML table that's outside of the visualization that shows the data that's in the viz. So that would be another way to kind of deal with that. You can use the new JavaScript Get Data API to do that. I actually have a link at the end of the session, at the end of the slides, to a blog post that shows you exactly how to do that. It shows you all the code you need to put in the web page to make that happen. So that's a good, and once it's in a standard HTML table, it is accessible. Screen readers will understand that and so forth.
Do you recommend HTML table versus just a CSV file or Excel file?
A downloaded file works as well. So the question was, do you recommend the table or CSV file or so forth? A file can actually be a good option if CSV or Excel file. That's another kind of stopgap, is if you just put a link to that data and download it, that is an acceptable way to meet this requirement. Yeah, it doesn't have to be in the visualization itself. Yeah. Another good thing to do is to provide a textual description of the visualization, usually in a caption. Even the default caption that Tableau creates will tell you kind of, what are the axes, what data is plotted on those axes, and so forth. And what this does is it allows someone who's using a screen reader to have an idea of what's in the visualization before they look at the actual data. So you could imagine that you're tabbing around a visualization and the screen reader reads, say, some text that says, this is a line chart showing this on the x-axis and that on the y-axis, and then they can use a keyboard command if they're interested to get to the table of data behind that. Something newer that's actually really interesting for this are some tools called natural language generation software. And what these tools do is that they allow you to set up a textual narrative kind of in a branching structure, and then they will generate a text narrative based on data that you send to them. So basically these are data-driven live textual narratives. So they create not just a static description of, say, the content of a visualization, but you can, kind of set them up so they'll say, if you're looking at a viz about home prices, it's like, home prices rose in the last quarter by 15%, and they would actually say that, and that's driven by the data that's in the actual visualization. And there are 3 vendors that have recently announced integration with Tableau: Automated Insights, Narrative Science, and EasyUp. That's how you pronounce the one in the right. And I've included links to their web pages that show how you can integrate them with Tableau to get basically a narrative alongside of a visual. We actually have customers who are already using these so that they, for example, can send out to a Salesforce, hey, here's your dashboard of how things are going, and here's some textual commentary on that dashboard. If you've ever gone to a stock website that's commonly used, like when you're researching stocks, and it seems like it wasn't quite written by a person, it was written by one of these. That's kind of how that was made. And the quality of the language really depends on how you set it up. If you set it up well, they read like they were written by a real person, not by a machine. So I think these offer some very interesting possibilities for accessibility. Actually, the hackathon winner this year from earlier the week was Automated Insights, and they showed how you can use the Amazon Echo to control a visualization and then have it tell you about the content of the visualization. So that was pretty cool. Okay, next guideline is about enabling different ways of presenting content. And what this is really about is helping people make sure that they can understand the relationships of various pieces of content to each other, and make sure that that understanding is not dependent on any particular sensory characteristics, so that you don't have to rely on, say, the position of something on the screen to understand what its purpose is. So my example down here, actually something that's pretty common in Tableau. In the left, I just have a little clip of a graph that has the label sitting on top of the graph. Or sorry, not the label, the legend sitting on top of the graph, but with no label. And that's a very common practice in Tableau. You turn off the legend title because you clearly can tell what it's for. It's sitting on top of the graph. Well, someone who can't see that graph doesn't know that. So the best practice is to make sure that you name your legends or filters or what have you in a way that it's clear what they belong with. So in this example, the graph is called Number of Students by SAT Score, and so I titled the label Legend for Number of Students by SAT Score. So you can imagine someone navigating around with the screen reader. They see a graph, and it reads its name, and then they get the name of the legend read to them as well, and so they know these things go together. Also, it's good to just make sure that you're super consistent and clear in your descriptions of things, and make sure to be very precise. Next set of guidelines is around making it easier for users to see content, and this is particularly about color. So one of the guidelines is that things that actually have information cannot be distinguishable only by color. There have to be some other way to distinguish those items. So remember the simulation of no color vision, and we had the histogram where you could no longer tell the marks from each other. So that's why this guideline exists. So best practices here, one, we have a colorblind palette in Tableau. A lot of people don't know that. So you can choose a colorblind palette, and that just kind of takes that particular impairment off the table if you choose that. And then also make sure that you use some technique to allow you to distinguish marks on a visualization from each other. So in this example right here, it's a multiple line chart. And what I did was I added a second axis to it. I made a dual axis chart with shapes that match the color of the lines. So now these lines are distinguishable from each other, not only by their color, but by the particular shape that's on top of the line. Another way to do that, or another potential idea, is to show labels for marks, or use some kind of beginning or end cap. A lot of times you'll see that where like the end of a line will have a picture next to it or something that helps you tell it apart from the other lines. In the same area of color, color contrast is a big one, particularly for people who have a contrast sensitivity loss. And this specifically applies to text, and to make sure that the contrast between the foreground color and the background color in the text is sufficient. There actually is a particular rule. It's a 4.5 to 1 ratio. In this example here, at the left, the word accessibility is not sufficiently dark enough on top of the slide background to meet that guideline, but the very dark gray text on the right is contrasty enough. There are great tools out there. There's one called Color Contrast Analyzer, which basically you launch it and it's got like a little eyedropper that you can, test the color of the foreground and the background, and it will actually tell you whether it's WCAG compliant or not in that language. You don't even need to know that number of ratio. All right. The next sets of guidelines are really about the descriptions and the labels and the text. So providing ways to help users navigate, making sure that, say, if you have a website link, the link itself describes what it is. You just don't have link or something like that, which is really common, or click here, because they don't know what's going to happen or where that goes. So this will enable people to be able to tell what the purpose of a link is. And then also just titles of filters and legends and so forth, that they explain what they're for. And the last guideline that's applicable to Tableau content is really the same, to make sure that you provide instructions on how to use the content. So if there's interactivity, you've provided instructions for it. All right, so let's look at a case study. I actually took a viz and figured out what was wrong with it from an accessibility point of view and then transformed it. So we're gonna go back to our old friend, the SAT example that I showed earlier. And so let's look at what issues it has from an accessibility point of view. So the first, we've already talked about this one several times, is that the marks are distinguishable from each other only by color. This violates one of the guidelines. Another is that the contrast ratio for some of this text is too low. So this particular visualization uses little vizzes inside of it as a navigation mechanism. It's an older one, so it was done to do some things that now are built into Tableau. But yeah, the yellow text on white, that's not contrasty enough. I mean, I think that's hard for even someone with perfect vision to see. That's just bad usability. Bad example. And the third major thing is there are just basically very few instructions or labels that tell you what this viz is all about, what's on these plots, and so forth. All right, so that's what it looks like. And then I hit it with the accessibility stick, and this is what came out afterwards. So let's go through and look in detail at all the things that I did to change it up. So the first thing that I did is I switched over to the new default theme in Tableau 10, and all the standard text colors there meet the contrast guidelines. So this is just standard, straight up Tableau theme, nothing special there, and the text colors work. The second thing that I did is that I switched to standard filter controls rather than those custom little vizzes within the viz to do the navigation. The reason for this is that we're working to make filter controls keyboard navigable. So once we get keyboard navigation, it'll be critical to have regular old filters to do your interactivity. I also added descriptive text and instructions up at the top. It's not important that you read it, but it basically describes what this dashboard is, what the filters are, and what they do. I also added descriptive captions for the graphs. So they explain, for example, percentage of students by SAT decile is a line graph showing percentage of students. SAT decile is on the x-axis, percentage of students is on the y-axis, and that basically can help someone understand what that data is all about. I made sure that the titles for the filters are referred to specifically in the instructions. So in the instructions it says, use the select academic year filter to select the academic year, and just make sure that I use the exact same titles in both places so that someone can clearly understand when they're on the select academic year filter, for example. Made sure as well, as I showed in an earlier example, that the titles for the legends state which visualization they're affiliated with. As I said earlier, created a dual axis chart to add shapes to this mark, or to the lines, so that you can distinguish them by something other than color. When you are able to get the slides for the presentation, I have this workbook as well, so you can see how I did that. It's not completely obvious. And then for the bottom histogram, I use shape marks rather than just circle marks, so that you probably can't tell it from the slides, but some are square and some are circular. So you can see it by another mechanism. Use the colorblind palette for all of the marks. And then some of the other things that I did are not specifically in the guidelines, but I think they're good practices in general as well. The guidelines are pretty straightforward. So I created a custom combined legend for the visualization. The way Tableau works right now is if you dual encode marks, so you say if you have a shape mark and you've encoded certain data on shape and then the same data on color, it'll produce two different legends. I'd love that not to be true. So there's like a little hack you can do to create a little visualization for your legend. And I provided a link to a blog post that shows you how to do that. It's a little bit tricky, but it actually worked pretty well. And then finally, I simplified some of the text that's in the viz to remove some redundancies. So the way the original visualization is, the categories and the filters refer to these academic divisions within the university. And they said, like, College of Fine Arts, College of Natural Science, College of Communication. And so I just got rid of College of. And the reason, this isn't in a guideline or anything, but the reason is that cognitive overload is a big problem with screen reader usage. If you ever used one or turned it on, it's sitting there reading everything to you, and it can be pretty difficult to deal with. People get really good at it, but it can be a little overwhelming. And the more verbose your instructions are, the harder it is for someone to be able to keep all of that in their head when they're hearing it. So the more concise and less repetition there is in the text, the better it is for someone who's using a screen reader. Okay, so that's what I ended up with at the end. I think in general, it turns into a cleaner, more easier to use dashboard for everyone. It's no longer a mystery how you operate it, what the various filters do, and so forth. So I think it's a good example of how following accessibility practices made something that's more usable by people who don't have disabilities. Yeah. Yeah.
Is there a reason you laid everything out with radio buttons and checkboxes so that it's all displayed as opposed to using a drop-down? Will the screen reader only read it if it's displayed?
So the question was, is there a reason I had everything displayed in the filters rather than using drop-downs? No, a screen reader would read everything. I just thought that it looked a little better and was a little more obvious how you use it that way. But that was just my personal choice. That wasn't an accessibility choice.
Okay, but if you have something with 100 options.
It would read it to you. Like the screen reader would say, drop-down list. It would read the title. It would say, select academic division, drop-down list, and then it would go through and read all of the options that are available to you. Okay, so what's coming in Tableau and when? Because right now, if you did all these things, that viz still doesn't meet. Today in Tableau 10.1, that viz still would not be accessible because you can't keyboard navigate it. Screen reader's not going to be able to read all that stuff to you that we just made. So what's coming? All right. So again, just to make sure that we're very clear on what we're doing, 4 workbooks that are published to Tableau Server online are public and embedded in a conforming web page, or just access directly with the viz with the embed tag in it. So the only thing you see on the screen is the viz itself, no surrounding Chrome from Tableau Server or online. We're adding keyboard navigation. This means things like getting rid of keyboard traps so that when you've tabbed into something, you get stuck there, you can't get out of it, as well as focus indicator so that you can actually see where the focus is as you've gone through the visualization. Assistive technology support so that screen reader will be able to read all that great text that I just added. and accessible view data functionality. So this will, means you can get to the view data page behind a visualization and then navigate it. And that will also allow you to download the data as well. And that's automatic because then you can open up that data in some other program. And then finally, we'll be publishing guidelines for how to do all of this stuff in the content. You can think of this presentation as kind of a rough draft of those guidelines so that we can teach you how to make these changes and follow good accessibility practices. And all this is going to be coming in 2017. A lot of it actually very early in 2017 and more throughout the year as we kind of flesh it out. So that's something we're actively working on right now. And I'm really excited about getting it out to our customers. The beta program for this is actually coming up really quickly. I think within the next few weeks, we'll have our first public beta of the next version of Tableau, which includes this functionality. If you are interested in participating in the beta program, write down that or get the slides later. Zai Krostag is the program manager or product manager for this work, and he can get you set up with the beta program. Make sure that he's communicating with you directly so that we can get some good user feedback on it. One of the other things that we're doing, we are working with a third-party consultant to help us make sure we're making good choices and such on this, and they're going to be setting us up with some testing with people who use assistive devices to make sure that everything we're doing actually works. All right, we're coming towards the end. I mentioned all the references that I give. So here are all the links. These are all live links. Standards and laws, basically WCAG, Section 508. A link to the page that specifically talks about Section 508 and the WCAG and talks about how they're expected to adopt the WCAG formally. And then the European Accessibility Act. Tools and tips, this first one is a blog post. It has nothing to do with Tableau. I just found it to be a really useful blog post about accessibility in UIs. It's by a UI designer for the web somewhere. Color contrast analyzer, that's that tool for testing the contrast of foreground and background color. It's a free tool that you can download. It comes from the UK, which is why it's got the UK spellings of things. And then there are a couple of other blog posts that show how to do some of those tricks. The first is how you create an HTML table from the data. That's a great one because you can pretty much copy and paste the code that they have in there into web pages. And then finally, how to create that little fancy custom combined legend that I made. There's a great blog post from the community on that. And those last two are both from the community, so it's really cool how some of that stuff is out there. The natural language generation tools. So these are links to basically the pages at these companies where they talk about their integration with Tableau. And then finally, the screen readers, links to their websites, so you can go check those out. And to get a good sense of it, you can just turn on the built-in screen readers on your computers, Narrator in Windows and VoiceOver on Mac, and that gives you a sense of what they're like. It also exists on mobile devices as well. So I've not done it on Android, but on iOS, you can turn on VoiceOver as well, and it kind of changes the way the interaction works, and it reads stuff on the screen to you. And just advice, if you haven't used one before, make sure you know how to turn it off, because it'll be overwhelming. It takes some time to get used to it. Most everybody has the same reaction, which is, oh my God. So that's the end of things. Again, what I wanted to do today was make sure everybody had a good basic understanding of accessibility concepts, know what the standards are around web accessibility, and how you apply those standards within Tableau, and then finally what we're doing to help enable all of this. I'm not repeating this session, this is the repeat. There are several other good sessions that I think they're not about accessibility. I think all of them have happened at this point. Oh no, Format Your Way to Fab is right after this. They're not about accessibility, but they're just, the more you know about how to use Tableau, how to build good dashboards and such, the easier it will be for you to build good accessible dashboards, just more tools in your tool belt. And then there's another session that's a good one about our JavaScript API, in case you're interested more in that, because that's also how the natural language generation tools interface with Tableau is through the JavaScript API. And that one was earlier this week. And so, after the conference, you'll have access to all of the materials and recordings of all of these sessions. So you can go check those out, and I recommend them. All right, my name's Kyle Gupton again. Feel free to stick around. I think we've got about 10 minutes for any more questions, or I can just field questions here as well. And before I forget, make sure to fill out your survey. It's always good to get people's input to help me improve these sorts of things for the future.